Chapter 4 next, on decimals and percents. Yeah, we see decimals every day. Anytime you're looking at prices of things, money, so dollars and cents. And yeah, maybe on your credit card statement, your annual percentage rate, maybe it's 14.99%, or sales tax 8.875%. So lots of decimal numbers all around us. We'll look at percents later in the chapter, but for now, what do basic decimals like this mean? All right, so decimals, yeah, they give us a convenient way to write fractions and mixed numbers using tens and powers of 10. So just to look at powers of 10, how does that work? Yeah, so 10 squared, 10 to the power 2, that's 10 times 10, 100. 10 to the power 3, 10 times 10 times 10, that's 1,000. Yeah, so the nice thing about powers of 10 is they're very easy to write down. So if you take a third power of 10, you just get 1 with 3 zeros. If you take 10 to the power 6, it's a 1 with 6 zeros. And so 1 million. You can see every time you multiply by 10, you get an extra 0. So if you multiply this by 10, 10 to the 7, that'd be 1 extra 0, so 7. All right, so this decimal we looked at, yeah, we have this decimal point here. And then if you look to the right of that decimal point, there are 2 digits. So we say this decimal has 2 places. Okay, the places, that tells us the power of 10 that we need. So here we have 2 places, so 2 to the power of 10, so that's 100. So we need a 100 on the bottom. And this number goes on top. All right, so yeah, so these decimals, we're really just dealing with a mixed number. We have a whole number piece here, 943. And then this, so the part to the right of the decimal point, that's the fraction part of the mixed number. So here it's 65 over 100. Okay, so this decimal, you could read it 943.65, or you could also read it 943 and 65 hundredths. How about this one? 16.104. So now to the right of the decimal point, we have 3 places. So we need 10 to the power 3. That's 1,000 on the bottom. And 104 is on the top. And this is the whole number piece, 16. All right, so this is 16 and 104 thousandths. Again, a mixed number. So the point of decimals is they're just mixed numbers, but we always have a power of 10 in the denominator. Makes the fractions easier to handle. Okay, so we'll look at two different ways to understand decimals. So the first way is to see that the decimal point, it separates the whole number part from the fraction part of the mixed number. Okay, so for the whole number part, right, then the decimal point always goes to the right of that, and then everything to the right of the decimal point tells you the fraction part. So that's how the system works. Again, the whole number part here is 100, and the fraction part is 0, 2, 3. Yeah, there are 3 places, so it's 0, 2, 3 over 1,000. And yeah, that 0 looks a bit funny. We don't need it, so it's just 123 thousandths. Okay, so again, the decimal point is separating the whole number part from the fraction part. Also, yeah, you have to be a little careful. So where the dot is makes a difference. Yeah, so when the dot is down here, that means a decimal point. But if the dot's up here in the middle, that means multiplication. All right, so this means 3 times 41, so that's 123. Okay, so if the dot is on the ground, then it's a decimal point. But if it's in the middle, then it's multiplication. So just be careful when you're reading or writing these dots. Example 1, express these decimals as mixed numbers. Part A, 20.9. Part B, 8.875. Part C, 0.04. All right, so it's all about counting the places. And right here we have 1 place in the first one, so we just need a 10 on the bottom. 20 and 9/10. Here we have 3 places, so we need 10 to the power of 3, 1,000 on the bottom, so 8 and 875 thousandths. Okay, so 3 places means a 1 with 3 zeros. Here 2 places, so we need 100 on the bottom, and 0 for just 4. We'll talk about unnecessary or insignificant zeros later. And the whole number piece here is 0, so we can just, you don't have to write it. There's a 0 here, but it's 0, so you can ignore it. And yeah, these last two, you can't simplify these fractions. So, for example, 4 over 100 is a common factor 2. In fact, the greatest common factor is 4. So if you cancel 4s, you get a simplified fraction 1/25. Okay, yeah, so usually we want to simplify fractions as much as possible. All right, so 0.04. So this decimal, as a fraction, it's 4 over 100, or 1 over 25. And we can go the other way, write these mixed numbers as decimals, 4 and 7/10. Okay, so going backwards, yeah, there's a 10 on the bottom, so we need one place. So 4.7. Counting zeros here, we have 4 zeros. So we'll need 4 places. So it's 2. Yeah, we have a 99 on top, but we need 4 places, so we have to put in 2 zeros here. So 2.0099. Okay, you can double check if you convert this into a mixed number. Yeah, it's 2 and 99 over 10,000. All right, so yeah, a lot of what we're doing is counting places, counting zeros, powers of 10. This last fraction, 23 over 100, we need 2 places, so it's 0.23, and yeah, usually include a 0 here. Yeah, you could write it as just 0.23, but yeah, it kind of looks nicer if you include the 0 here. All right, I said there was a second way to understand decimals. So the second way is to look at each digit separately. Okay, for example, 98.76. All right, so that contains these digits, a 9, an 8, a 7, and a 6. And what do each of these represent? Okay, so in this decimal place value system, depending on where the digit is, it has a different meaning. So this 9 really means 9 tens. This 8 represents 8 ones. Okay, so the digit to the left of the decimal point, that's always ones. The digit to the right of the decimal point, that's always tenths. So that 7 means we're including 7 tenths. 7 times 1 over 10. And as you go further to the right, the digits represent smaller and smaller pieces. So this 6 represents 6 hundredths. 6 times 1 over 100. All right, so we're going digit by digit. All right, and then you add them all up. So we get 9 times 10 plus 8 times 1 plus 7 times 1/10 plus 6 times 1/100th. That's equal to this. 90 plus 8, that's 98. And get a common denominator here, 100. So you can write this as 70 over 100 plus 6 over 100. So that's 76 over 100 plus the 98. All right, so yeah, that's just the mixed number. We've got back to the mixed number we were expecting. All right, so yeah, we're just saying here for a decimal, you can break it up into these small pieces, and then when you recombine them, you just get the mixed number. But this is useful too, to think of it this way. All right, so if you see a decimal, so first, let's see where the decimal point is. Then the digit to the left of that tells you how many ones. To the left of that, that's the number of tens, and hundreds, and thousands. So every time you go left, you're multiplying by another 10. The digit to the right of the decimal point, that tells you the number, that's always the number of tenths. So 1/10. To the right of that, the number of hundredths, 1/100. Thousandths, 10,000ths. So they get smaller and smaller. And yeah, we were looking at 9876. All right. Okay, so just memorize this. It's always the same. You've got ones to the left of the decimal point, tenths to the right. Decimal, yeah, the word decimal means tenth in Latin. Yeah, everything's based on tens. So yeah, just powers of 10. 10 to the power 1 is just 110. 10 to the power 0, anything to the power 0 is 1, so you can think of the ones place as it's still related to tens. And then when you go past the decimal point, then you have reciprocals, so 1/10. So 1/10 to the power 1. You can write that. There's a special notation for reciprocals, negative powers. So another way to write 1/10 is 10 to the power -1. All right, so that's tenths. Then hundredths next. That's these guys. So 1/100 is 100th. Okay, these THs are important. So 1/100th, that's 1/100, or 1/10 to the power 2. And you can write that as 10 to the power -2. And 1,000th, 1/1000, 1/10 to the power 3. That's 10 to the power -3. Okay, yeah, so we're not using negative powers much, but just remember, yeah, it doesn't mean the whole thing is negative. It really means a reciprocal. So 10 to the power -7 means 1/10 to the power 7. Example 3, for this decimal, name the digit in A, the tens place, and B, the hundredths place. So yeah, be careful. It's not the hundreds place, but the hundredths place. Okay, so the decimal points here. So this, the 4 represents ones. The 0 represents tens. The 9 is hundreds. So yeah, we have a 0 in the tens place. Three. So on this side of the decimal point, that's 3/10 and 2/100. So there's a 2 in the hundredths place. And there's an 8 in the thousandths place. All right, so we're just using this this diagram. Tens here, hundredths here. It's maybe a bit confusing. It's not quite symmetrical. So yeah, tenths here. Maybe it's easy to think that there are tens next to the tenths, but no, there's ones in between. Okay, yeah, note that every whole number can be written as a decimal. For example, do you see where the decimal point goes for this number, 65? So where does the decimal point go? Does it go here? No, I mean this. If this is 65, then this should be 5 ones and 6 tens. So the decimal point has to go to the right of the ones. So for a whole number, the decimal point is always goes on the right side. Okay, yeah, you could write it as 65.0. That's the same as 65. All right, so to convert a whole number to a decimal, just put a dot on the right, low down. All right, yep, chapter 4, powers of 10. This, yeah, this is the formula I was mentioning. Yeah, so negative powers mean reciprocals. Yeah, we have positive powers of 10 on the left, then the decimal point, then negative powers of 10, those reciprocals on the right. Let's look at this example. What is the digit in the 10,000ths place of this decimal? All right, so 10,000ths. Well, let's count. So we have tenths, hundredths, thousandths, 10,000ths. Yeah, so it looks like that 8 is in the 10,000ths place. Okay, so just count. Start at the decimal point and go to the right. Next section, significant and insignificant zeros. Yeah, these insignificant zeros are the ones you can remove from a decimal without changing its value. So you can see, yeah, these two zeros here, they're not really necessary. You could certainly remove them, and you haven't changed. It's still, the whole number part is still 340. Okay, this zero, yeah, you have to keep that one. If you got rid of this, the 340 would change into 34. But this guy on the end we can get rid of. And from our second point of view, it's just telling us that there are no these are tenths, hundredths, thousandths. So there are no 10,000ths. And so if we remove this zero, then it doesn't change the number. But yeah, we do have to keep these two zeros in the middle. If you remove those, then you do change the number. Okay, so those are these two are significant zeros. If we remove them, it changes the number. But for insignificant zeros, you can remove them. Okay, so we have a rule. Zeros to the left of the whole number part or to the right of the fraction part are insignificant. Other zeros are significant. All right, so zeros on the end. So to the left of the whole number part or to the right of the fraction part, you can remove. They're insignificant. But all the other zeros you have to keep. Okay, and just an example here. Simplify these decimals by removing all insignificant zeros. All right, so this zero, it's to the left of the whole number part. These two are to the right of the fraction part. So get rid of them. All right, there are no zeros to the left of the whole number part. There is a zero to the right of the fraction part. So we can get rid of this. It's telling us there are no tenths. And so this decimal just, it's really just a whole number. Okay, yeah, these zeros we have to keep, and this one. Okay, so yeah, it's a little tricky. Okay, no insignificant zeros in the fraction part here, but these two we can get rid of. They're to the left of the whole number part. So yeah, you could get rid of them both. Or like I was saying before, it's nice to keep 1 0. So if you're writing a decimal that has no whole number part, then yeah, usually it kind of looks nicer if you write 0 point the rest of the decimal. So this, this is the preferred way to write it. But this is correct too. Part D of this example, yeah, so I hope you see there are no insignificant zeros here, so this doesn't simplify. We need to keep all of these. And this one looks symmetrical. Is this confusing? So this is the whole number part. Okay, so checking our rule. So zeros to the left of the whole number part are insignificant. So it's these two we can remove. So this number, it's really 900. Like I was saying before, there is a kind of a hidden decimal point. It's here on the right. So yeah, we usually think of 0 as just meaning nothing. You can usually ignore it, but you can see some zeros you can't ignore, and they do mean something. It's this place value system. So these zeros here are telling us there's nothing, no ones, no tens, but we need to keep them so that we can write the 6 in the right place. The 6 represents 600s. This 3 represents 3 10,000s. All right, so I hope that makes sense. And here's a nice application of those zeros. So when you're comparing two decimals, or we'll see next time when we're adding them, it's useful to add insignificant zeros to give them the same number of places. Okay, then you can line things up nicely. Example 5, which is bigger, 0.3 or, oops, something's missing. Yeah, that should be 0.28. All right, so this that was the question. Yeah, this first decimal has one place. This guy has two places. So a nice way to answer this question is to give this, add in an extra 0 to give this two places. Okay, so instead of simplifying now, we're adding zeros just to get the number of places to match. So if you add that insignificant 0 here, you haven't changed the number, but now it has two places. This has two places, and now we can compare them as a fraction. This is 30 over 100, and this is 28 over 100. Yeah, so now we can see that this guy is bigger. So 0.3 is bigger than 0.28. All right, so yeah, without the 0, this 0.3 as a fraction, it's 3 over 10. So you're comparing 3 over 10 with 28 over 100. And just like when we were working with fractions, yeah, you need a common denominator to compare fractions. So we're really doing the same thing. So writing decimals with the same number of places is really using a common denominator. All right, so this is the same, comparing decimals. Let's look at this example. Arrange the decimals in descending order from largest to smallest. Okay, so now we're comparing 3. So this first one, 0.102, this is 3 places. This one has 5 places. This one has 1 place. Yeah, the middle one's 5 places, so I'm going to we'll give these other 2 5 places as well. Okay, so we need an extra 2 zeros. So add those insignificant zeros on the right. Keep the middle one the same, and then add, it has 1 place, so we'll add 4 more zeros to give it 5 places. All right, so now we can compare the 3 decimals more easily. Okay, so we have 5 places, so we have 100,000 on the bottom of each of these. On the top, we had 10,200. On the first one, 9,876 on the top of the second one, and 20,000 on the top of the third one. Okay, so the denominators are the same, so we can just compare the tops. And we're looking for the biggest to go first for descending order, so 20,000 is the biggest top. Then the middle top is 10,200, and the smallest top number, 9,876. Okay, so the third number is the largest, the first number is the middle, and the second number is the smallest. So using the original decimals, we have this. This is our descending order. So this is greater than this, is greater than this. So we're getting, we're descending in size, we're getting smaller. Okay, so again, it's the same idea we looked at, just comparing general fractions. You need a common denominator, and it's the same here. Write the decimals with the same number of places, then you can easily compare their sizes. Okay, and one last topic, rounding decimals, rounding off. The idea of rounding is to replace a decimal with a close, simpler number, maybe a whole number or maybe another decimal, but if you're rounding, you want something simpler. Let's go back to our credit card balance. If we wanted to round this amount of money, $924.83, to the nearest dollar, well, so which dollar amount is closer, $924 or $925 or $923? Well, you can see this amount of money, it's between $924 and $925, but it's only 17 cents from $925, so to the nearest dollar amount, it's 925. All right, so that's an example of rounding. So it's less accurate, but it's simpler. So to the nearest dollar, it's 925. How about if you wanted something even simpler? So another question, round the same amount of money to the nearest $10. All right, so now we're just working with tens, multiples of tens. So this amount, it's between 920 and 930. But yeah, I hope you can see it's closer to 920. So it's $4.83 away from 920. What would you have to add to get to 930? It's $5.17 away from 930, so that's further. All right, so to the nearest $10, it's, if you round this to the nearest $10, it's 920. All right, so I hope you get the idea. Let's forget about the money. Let's look at a kind of a general decimal. So just yeah, the same number. Another way to think about it, to round this number to the nearest 10, we first find the tens place. That's called the round off place. All right, so yeah, here ones, tens, hundreds. We're rounded to the nearest 10, so we find the tens place. It's got a 2 in it. Then the idea is to look at the place to the right. Okay, so that's the rounding place. 1 to the right, that's the next digit is a 4. Okay, so now we're trying to work out, are we closer to 920 or 930? So that depends on this number. Since we have a 4 and 4 is less than 5, so 5 is the middle, midway between 0 and 9. So since 4 is less than 5, that means we're going to keep that 2 in the round off place. And then make the 4 and every other number 0 and simplify. All right, so this decimal rounded to the nearest 10 is 920. All right, so I hope you see the steps. So when you're rounding, look for the round off place. Here it was tens. So you can put a box around that digit. Look at the number to the right of that. Check, is it less than 5 or is it 5 or higher? If it's less than 5, then keep the digit in the round off place the same. Everything else turns into a 0, and then eliminate any insignificant zeros. So just 920. Okay, example 6, round this decimal to the nearest 10. Okay, so very similar. We're rounding to the nearest 10, so here's the tens place. That's the round off place. Same as before. But now the digit to the right of that is 5 or higher. It's 7. Okay, so this time we have to go up. Now, since this is 5 or more, we increase that 2 to a 3. Okay, so the digit in the round-off place goes up to 3. And then everything else turns into a 0 again. These are insignificant, so the answer this time is 930. So 927.83 is, to the nearest 10, it's closer to 930. So this number rounded to the nearest 10 is 930. All right, so you can see, yeah, there's a complicated rule coming. So if you're rounding off, so you find the round-off place. If the digit to the right of the round-off place is 0, 1, 2, 3, or 4, then keep the round-off digit. But if the digit to the right of the round-off place is 5, 6, 7, 8, or 9, then increase the round-off digit by 1. All right, so there are two options. Either your round-off digit stays the same, or it goes up by 1. All right, so it never goes down. Either just stay the same or increase by 1. Just those two options. All right, so once you've figured out the round-off digit, then make all the digits to the right of that 0, and then simplify, eliminate any insignificant zeros. All right, so that's the plan for rounding. Example 7, round 413.098. A to the nearest hundredth, B to the nearest 100. Okay, part A, we're looking for, so where are the hundredths? So we have tenths, hundredths. All right, so we found the round-off place is here. It has a 9 in it. Okay, then use our rule. Look at the digit to the right of that. It's in the larger range. It's between 5 and 9. So then we have to increase that 9 in the round-off place by 1. Yeah, this is slightly awkward. The 9 plus 1 is 10. So yeah, the 9 turns into a 0, and we the 0 turns into a 1. Okay, so we have to the 0, 9 becomes 1, 0. So yeah, maybe a bad example, but we're increasing, so going up. And then the 8 turns into a 0. Okay, so we get this, and then simplify it. Yeah, these are now insignificant. They're to the right of the fraction part. So we get this answer. Okay, so 413.098 to the nearest hundredth is this number, 413.1. Yeah, I guess you could have included this you could have kept that 0 just to include the hundredths, but yeah, not necessary. It's saying this whole digit, it's closer to 413 and 10 hundredths. Your other option was 413 and 9 hundredths, but 413 and 10 hundredths is closer to this number, or 413.1. All right, part B, to the nearest hundred. Okay, so we see a 4 in the hundreds place. That's the round off place. To the right of that is a 1. And that 1 is in the range 0 to 4. So that tells us, our rule tells us that we keep the 4. And then make everything to the right of that 0. So we get these guys all turn into zeros. And we can eliminate 3 insignificant zeros. Oh, the answer here is 400. All right, yeah, so this is easier to see. Yeah, 413 point ... That's closer to 400 than 500 or any other hundred. So rounded to the nearest hundred, this is 400. Yeah, I guess a common mistake is to keep the decimal, keep the fraction part. Yeah, so the answer isn't 400.098. It's, yeah, make sure you zero out everything else. So we want a simplified number. So your rounded number should be a lot simpler than the original. So yeah, so this is certainly simpler, just 400 instead of this. So we've lost some accuracy, but we've certainly made it simpler. But yeah, it's a kind of a complicated procedure. Here it is. Again, this rule for rounding. Let's do one more. Round 6.597 to the nearest hundredth. Okay, hundredths, so tenths, hundredths. So the rounding place is here with a 9. Okay, I can't see what's next to it now. So 9 in the rounding place, a 7 to the right of that, and the 7 is 5 or higher. So that tells us that, yeah, we have to increase that 9 by 1. And yeah, this is similar to the example we saw. So yeah, we have to include the 5. So if you increase 9 by 1, it kind of carries over, and we get the 59 turns into a 60. And that 7 turns into a 0. But it's insignificant. Yeah, so yeah, that's optional. You can, if you want to include the hundredths, you can include that 0, but it's, yeah, really 6.6 is the answer. All right, so again, just to summarize. So when you're rounding a decimal to a given place, that's the round off place, preserve the digit in the round off place if the right neighboring digit is less than 5. Otherwise, increase the digit in the round off place by 1. And yeah, if it's a 9, then increasing by 1 affects the next number to the left as well. Replace all the digits to the right of the round off place with zeros and eliminate any insignificant zeros. All right, so there'll be some examples to try in the homework.